Thanks, guys. Um, it gave you some background. I'm gonna go backwards in time. 2008, I had one startup, and it was in the housing market, and I started. Housing market crashed in 2008. For anybody that doesn't remember, so I started a company called Cross Browser Testing, which was all about making it so you could see web browsers the same across all these platforms. And by the end of it, we had Macs, we had PCs, we had iPhones, iPads, Android devices, all the way back, all these iterations. And when something broke, it was impossible to tell what the heck was going on in the system. We were jumping from one system to another system to another system, and ultimately ended up on a phone that was not reliable. So testing was very difficult, and distributed testing across distributed systems was very tough. And that's what led me to trace test. And I'll be showing that as we go through it. Also had a stint at SmartBear for about 4 years when I acquired the company, and SmartBear is very big in the enterprise test space. All right, so we're kind of getting the core of this presentation is a story about stuff that happened this summer, but we're going to start off just a level set on a short primer on observability. Who knows what a distributed trace is? Okay, well, I'm going to spend 45 minutes going over that. No, not. I'm going to spend 4 minutes going over that just for the people. Exactly. So we'll do the 4-minute, what is observability? And then we'll talk specifically about OpenTelemetry, which is a standards-based approach to observability. And then we'll kind of get in the story talking about cloud native app. And spoiler alert, it is the app that the OpenTelemetry CNCF Foundation puts out for you to learn about OpenTelemetry. And there's also a derivation of it that the OpenSearch community put out, and we'll cover that a little bit. And then we'll talk about the troubles. There were some issues in May timeframe. We'll show the beginnings of it and then what the solution was. All right, so walking out of here, you should have some knowledge about the OpenTelemetry project and both their version of the community demo and the OpenSearch version of it. You'll have links to both repos, and it's a pretty complex repo. It's got 11 different languages being used in it, 12 different services. It's got some good complexity in it. And you can easily, if you got Docker, you can easily install it. And as of today, it comes with a full suite of tests, and we'll look at those tests as we go through this. And we'll see how trace-based testing can reduce effort and increases confidence when you're deploying code. So it's basically, observability has typically been used post deployment. So you deploy, you're in production, you've got problems, you use observability to fix things. Trace-based testing leverages that same visibility in your CI/CD pipeline to prevent problems from getting out there in the first place. Okay, so a little primer on what is observability. Observability is the ability to measure the internal states of a system by examining its output. And I interpret that to mean if you look at having a problem in production, if you can't look at your observability signals and determine what the problem is, then you still have work to do on making your system observable. If you have to put in new code to expose some other variable that you didn't think of, then you're not there on the journey of making it observable yet. There's typically 3 signals they talk about. I've been doing logs. I think I may have been doing logs when I had punch cards. I'm not sure how that worked, but very quickly was doing logs. In the 2000s, we started doing metrics. Probably, 2014 era, started doing distributed logging and using the Elk stack at my company. And then it's moved into traces. And we're going to specifically talk about distributed traces today. So what is a distributed trace? It records the path taken by requests as they move through your system. And it basically shows you a burn down chart of exactly what happened with individual calls. So when you look at it, this is what you see. So the client places a call to API, which calls a authentication service, which calls another authentication service. And then it returns back up to the API, which calls a payment gateway, and so forth. You get a lot of detail from this. You get timing. You can see how long things took. You get call order, so you know what was called when. And if you click on each of the The full thing's called trace. Each element is called a span, and this kind of represents the operation that occurred. And then if you click on a span, typically any of the tools are going to show you attributes underneath these. So there are details about that specific span, how long it took, when it started. If it was like a HTTP request, it might show you the path that it did, whether it's a post or a GET, etc. So a lot of detail given in these traces, and they're great in a production situation when you're trying to troubleshoot. Okay, that was my 4-minute observability primer. So now we're going to talk a little bit about OpenTelemetry. We'll start off with a little video. A few years ago in a galaxy not so far away, we had observability wars. And this is episodes, the emergence of a standard. It's a period of confusion and discord in the open observability space. Vendors are attacking the wallets of kind, good-hearted dev groups across the world. With proprietary APM tooling, they enslaved code bases, making escape and freedom a distant dream. Open source standards are desperately needed for instrumenting, but there are multiple standards and no clear leaders. Zipkin, open census, open tracing. Can the open source forces be channeled? And with that, we did. We found one standard to rule them all, which is OpenTelemetry. And so what is this OpenTelemetry standard? Who's heard of the OpenTelemetry CNCF project? Okay, great. Okay, so what is it? It's a way to instrument your code to get traces, metrics, and logs. And of the three, traces is the area that they developed the first, and it's the most mature of the three. So it gives you a standard way to instrument. I think it's useful to say what it is not. It is not a way to analyze your telemetry data. So it's all about collecting it and getting it to a platform such as OpenSearch, where you can look at the traces and analyze them. It's got widespread adoption by both open source and vendor-based observability tools, including OpenSearch. So OpenSearch has a dashboard where you can see your telemetry information. And I've got a couple more screens for it later. Okay. So now I'd like to talk about a cloud native app. And the one I want to focus on is the one that the OpenTelemetry CNCF group put out, and it is a demo. It's easy to download. If you type OpenTelemetry demo, you're going to get to it. They've got great docs on it. Easy, you can install it in Docker or Kubernetes. Why did they write it? They wanted a way to show people with a fairly complex microservice-based system, how do you instrument these things? So you've got the standard, there's no substitute for seeing real code to see how things work. So they built it for people learning. They built it for vendors who are trying to work with OpenTelemetry and want to make sure their software works. We use it, and OpenSearch has created a derivation of it for their environment. So it is available in GitHub. So you go to GitHub, you'll see this page. If you scroll down a little bit, you're going to see different vendors that are utilizing this. And at the top right, you'll see OpenSearch is one of the vendors. So they cloned it and created their own branch of it, their own version. And you can go to that version at OpenSearch project OpenTelemetry demo. You can download it. You can install it Docker or Kubernetes. And it's really a quick and easy install. And I encourage you to do that. Okay. And there's a couple of screens. I used that version and installed it on my laptop and got a couple of screens from it. So this is a trace visualization in OpenSearch. So this OpenTelemetry demo is a store, and it's for astronomy, for telescopes. You can go in, it's got a web front end written in React. It's got a back end made up of tons of different languages. And here's a list of the languages on the left. I think that's 11 different languages. And there's a bunch of different microservices involved in this process. So it mimics a fair bit of complexity that you might have in a real enterprise using microservices. There's one service we're going to look at as we go through the presentation, and it's the checkout service. All right, a lot going on there. Anybody's system at work look similar to this? Yeah, yeah. Mine was worse. The one I built for my last business, it was uglier than this. But a lot of complexity, and this is where distributed tracing really comes in. Is so much complexity. There's no way you're going to open up a log file for each of these microservices, look at the logs, and figure out what's going on. That's where distributed tracing really pays off. So we're going to focus on the checkout service, which is kind of in the middle of things. And just to point out some things, I'm back to the OpenTelemetry version of the demo. Yes, 1,000 stars, a lot of forks in a given month, 58 active pull requests, 15 different authors. These people are all over the world. They're open source contributors. They're not being paid. They work for different companies. A lot of them work for the different observability vendors. They're pushing commits. So let's do a little bit of math. So we had 11 different languages from PHP to Elixir. We're using both manual and automatic instrumentation. So manual instrumentation is when you put in the code, very specific code to create your own span and set your own attributes. For automatic instrumentation, it just happens for you. Certain languages have great automatic instrumentation, certain ones don't. Java is an example one that has really nice automatic instrumentation. So in that month, there were 46 pull requests by 15 different people. And I'd like to have the country count because I think it'd probably be, 12, 13 different countries. And there's a lot of complexity in the demo, a lot of different protocols being used, a lot of different technologies being used. So what could possibly go wrong? In my experience, everything always goes wrong. So lots of potential for issues. How do you mitigate issues? You have tests. So you catch these things. But they had tests, so that's cool. They had tests written in Ava. They had front-end tests, and then they had their back-end tests were written in Ava. Here's an example when they're Ava tests. So they had some complexity, but they covered it with tests. So
looking good, Billy Ray.
Feeling good, Lewis. Life is obviously good. Now I've got to ask, who in the room actually remembers this movie? Okay. This is an age test, obviously. So it's a great movie, though. Okay. So Trading Places. Trading Places, yes. So life was not good, as we found out this summer. And this is really, we're getting the storytelling part of this. In May, there's a CNCF group responsible for the demo specifically, and they've got a lot of contributors and is very active. And in the CNCF Slack, which if you haven't joined it and you're interested in OpenTelemetry, is a great resource. In it, one of the core contributors said, hey, does anybody have any experience with using trace-based testing? He's basically like, we need to have better testing that does full end-to-end testing. And he went on to state that he'd put in some changes and he broke things, and he broke it for several weeks before he realized it was even broken. So you've got people all around the world trying to learn OpenTelemetry. They're relying on the demo. They're downloading it. Things aren't working right, but it takes a while to get those signals back from everybody that there might be a problem. And he was wanting ideas for improving the testing. And then another contributor, this guy actually works at, and he's the product manager for Instana. He was saying, hey, first time I did a PR, I was scared to death I was going to break something, and echoing that wanted better testing. So they put in a feature request, basically spelling out the problem. 23 services and counting, small changes have unexpected results. Testing all possibilities not realistic for committers and improvers. And then another person echoed in that they wanted to make this part of their CI/CD process. So these tests ran as they're moving through production. All right, so to the last part, I want to talk about how they use testing based on observability and introduce a term called trace-based testing, and it's a new way of doing testing. If I go back to technology changes since 2005, and we talked about it earlier, we started doing metrics, and then we started doing distributed logging, and then we started doing distributed tracing to get better visibility in production. But I don't think our testing has changed very much. Our testing is still typically black box tests. We hit API, we get the response, we look at it, and we say good or bad. That's great on a synchronous system that bubbles up every problem to the call. If you've got an async system, tons of times, and with my last business, even back in 2013, if you hit the API, we'd give you a 200. Just all it meant was we got the request. You didn't know if anything worked past it. So trace-based testing gets a second source of input besides the response, and it is the distributed trace. So it grabs the trace that is triggered by the test and allows you to put assertions on not just the response, but also the trace. Ted Young was one of the co-founders of the OpenTelemetry project, and he presented a conference back in 2018 talking about the concept. I think this is the only commercial slide I have for the open source project, which we've now released as a service also, called Trace Test. I'm founder. It is a tool that allows you to do trace-based testing. It's got both a GUI and a CLI, and it works with whatever your existing tracing solution is. So if you use an OpenSearch to store your traces, we have a simple configuration screen. You put in like 4 things, you tell us your API key, etc., and we can connect and get your, I think, index. We need the index for OpenSearch, so we know where to get the trace from, and you're up and running. You can install it in Docker or Kubernetes, or use our new online service. That's my full commercial. So that's it for the commercial. All right. So kind of talked about testing changing. So the old way to test, you trigger a test, you get back a response, write assertions against it. You know, Insomnia does it, Postman does it. SoapUI was a product from SmartBear. They did it. I would call those tools response test. So you can test against the response. Trace-based testing, you trigger a test, you write assertions against the data in both the response and the distributed trace. It gives you a lot more ability to quickly write end-to-end tests, which I've written too many of in Python in my day. Typically, if you were to look at them, the tests would be this long, and all of this was stuff to get visibility. It was, okay, I'm gonna connect to the database, and I'm gonna get this value, and I'm gonna gather all this information, and at the very end of it, I'd have, and I wanna make sure this equals this, and this is less than this. So the assertions was a very small part of the code. The big part of the code was getting visibility. Trace-based testing leverages visibility you've already got by implementing distributed tracing. So we add more value. If you've already done the work of embedding tracing into your system, you can leverage it to make integration and end-to-end tests super easy. So they asked for help. Daniel on my team volunteered to write the test for the OpenTelemetry project. He organized it into different folders based on the main service that he was testing. And we're going to look at the checkout service. And we're going to look at, this is a actually being run as a transaction. So it like looks at the shopping cart, puts something in the shopping cart, and actually the one we're going to be looking at is actually checking out. This is a view of the transaction. So you can see the different steps in the test, and this is those tests once they've executed. We're going to look at that one specific test, which is part of the test suite, and look at how the tests are represented. And all of this is in the repo for the OpenTelemetry community demo. So if you download the repo, you'll have these tests. You can run these tests. The first part of it is the trigger. So we see it's all in YAML. Here's the trigger. We're going to hit this URL, and we're going to do a post against it. And here's the body data we're going to send. And then the second part are the series of assertions that Daniel wrote. We're going to focus in on a couple of them. The first one is probably the most basic API test anybody does. I want to see if you got back to status code of 200. So you check the test status code. That's probably been done more than any other API test. The second one's a little deeper though. It's looking at one of the spans in the test to look to see if an order was placed. And it's utilizing visibility exposed by the trace to ask that deep question. So this is an example of running this test, and the span that we were looking at is highlighted. If you click on that span, you can see the attributes for the span. One of the attributes is app order items count. So that would be an example of manual instrumentation. So the people, whoever wrote this microservice, added a piece of manual instrumentation so that when they're looking at it in production, they could tell what was going on. We can also leverage that in our tests. So we're going to add a test to say we expect the order items count to be 1, and we can save that test. And at that point, we have a test that's ready to run in CI/CD. So you lock those tests down in GitHub, just as they did in the OpenTelemetry demo, and you can run the tests with a Docker Compose run, the trace-based test. It's an example of it running. So it goes, it's very descriptive. Daniel did a good job naming the tests. So it's very descriptive as you go through and you see the test run, you get a good description of exactly what it was testing. And it was testing throughout the entire flow of the process. So recapping what we talked about, the short primer on observability, we talked about what OpenTelemetry is and the standard. We've looked at the cloud community demo, heard about its troubles, and hopefully seen how building tests based on observability can help. So my challenge to you, if you have Docker, you can run these tests also. You can pick which repo to go after. If you want to go after the OpenSearch repo, you can download and install it, or you can go to the OpenTelemetry and download it. I think there's pros and cons to each of them. The OpenSearch demo is up to date. It's the OpenSearch version's probably 3 to 4 months behind on updating it. So if you want the latest and greatest, you go to the OpenTelemetry version. If you want to see it running on OpenSearch, I would use the OpenSearch version. Both of them have the test in there where you can run the tests and see them and modify them. So here's the OpenSearch version. And that's it.